Let's explore the nature of the chemical bond in table salt or sodium chloride. The question is, what type of bond exists between sodium and chlorine atoms in salt? Let's understand this by looking at the atoms involved. First, we have sodium. Sodium is an alkali metal with 11 protons in its nucleus. In its neutral state, it also has 11 electrons. The electron configuration shows 2 electrons in the first shell, 8 in the second shell, and 1 electron in its outer shell. Next, we have chlorine. Chlorine is a halogen with 17 protons. It has 2 electrons in its first shell, 8 in its second shell, and 7 electrons in its outer shell. Notice that chlorine's outer shell is 1 electron short of having a full shell of 8 electrons. When sodium and chlorine come together, something interesting happens. Sodium's single outer electron is transferred to chlorine. This creates 2 ions, a positively charged sodium ion, Na+, and a negatively charged chloride ion, Cl. The opposite charges of these ions create a strong electrostatic attraction. This type of bond, where electrons are completely transferred from one atom to another, is called an ionic bond. In sodium chloride or table salt, this ionic bond holds the sodium and chloride ions together in a crystal structure. Therefore, the bond between sodium and chlorine in salt is an ionic bond, characterized by the complete transfer of electrons from sodium to chlorine, creating oppositely charged ions that are held together by electrostatic attraction.